Okay, in this video we're going to talk about profit maximization in the monopoly model. So remember that monopoly is the only supplier of a good for which there is no close substitute. While we don't have many perfect monopolies today, we can use the monopoly model to really discuss companies that have a dominant market share. Okay, so it's more flexible and more helpful to us than that would otherwise suggest. All right, so remember, a monopoly can set its price. It's not a price taker. And all firms maximize profits by setting marginal revenue equal to marginal cost. Remember that that was also the profit maximizing rule under perfect competition. All right, so marginal revenue and price. Let's begin by talking about what revenue is. Revenue is price times quantity. We want to see how marginal revenue and price are related. Remember, in perfect competition, they are equal to each other, but not so in monopoly. Okay, so marginal revenue is always going to be less than the price. So marginal revenue is the change in revenue from selling one more unit. So if we have a revenue function, we take the derivative with respect to Q, and we get the partial derivative of R with respect to Q, or change in R divided by change in Q. All right, let's take a look at a graphic where we compare perfect competition to monopoly. On the left, as I increase Q by 1, I get B as the extra marginal revenue, or as the extra revenue. So notice here that marginal revenue is just price, P1, because it's the area B, which has a height P1 and a base 1. And then we look at the right-hand side, and how does that differ with monopoly? Well, monopolies have downward sloping demands, so for them to increase sales by 1, they have to drop the price to do it. That gives them an area of gain and loss of revenue. So initially, the revenue is C plus A, and then after the change in price, it's A plus B. So B is the gain and C is the loss. If we take a look at the marginal revenue, we balance B and C. Right? So it's B minus C. B is what we gain, the new sale at the lower price. And then the loss is all of the previous sales where we had to drop the price. It's that change in price on previous sales. Okay, so to increase output, the firm lowers its price per unit. Right? So the change in price divided by change in Q, where change in Q is just 1, that's the lower price. Okay, so that's equal to the slope of the inverse demand curve. Let's take a look at that demand curve that I've written. P is 20 minus 0.02 Q. Remember that coefficient on Q, 0.02 or negative 0.02, that's the change in price divided by change in Q. And what that says is, for every increase in quantity, what is the required reduction in price for that to occur? So if we want one more person to buy the product, we have to drop the price 2 cents. So by lowering the price, the monopoly loses that original quantity Q times the change in price that we saw divided by change in Q. Right? So think about that 2 cents that we had to drop the price to sell one more unit. So it's the 2 cents times all previous units sold. That's that loss box that we saw earlier. But now it earns an additional gain, which was the new area of revenue, which is equal to 1 unit times the price, the new price. So I'm balancing that gain. So what's the marginal revenue? In total, it's the gain, P, right? The new unit sold at the price, the new price, and then plus the loss. So the change in P divided by change in Q, in our simple demand function, that was negative 0.02 times the number of units I had sold previously. So I'm balancing the gain with the loss. This relates to the elasticity of demand and also where we maximize revenue. So notice here that demand is downward sloping and P is equal to 24 minus Q. That's our demand function, right? And that gives us the blue line. Marginal revenue starts at the same intercept and then is twice as steep. because for every unit we sell, we have an opportunity cost loss box that's getting bigger and bigger. And so that means the marginal revenue is always less than the price. Marginal revenue is always less than the price. Let's think about this in terms of elasticity. All right? Notice that above the midpoint of the demand curve, where elasticity is -1, we have the elastic portion, and below it we have the inelastic portion. All right? Now remember that at the midpoint, revenue is maximized. Well, let's relate that to marginal revenue. Notice that for units before 12, when I increase quantity sold and drop the price, I end up increasing revenue because we're in the elastic portion of demand. And then once I hit that MR of 0, I've maxed out my revenue. So for the last unit provides no additional revenue, I can't get any more revenue. And now any further attempts to increase sales and drop the price gets us into that inelastic portion of demand, and that's where we lose revenue. So MR is negative. So when MR is positive, we're on the elastic portion of demand. Where it's negative, in those quantities, we're on the inelastic portion of demand. Now I've got to cross through the inelastic area of demand. We would say that it wouldn't be good for firms generally to ever be on the inelastic portion of their demand curve, where MR is negative. And the reason for that is because, gee, I can produce less, right? Raise the price, and I can make more revenue. Not only that, because I'm producing less, my costs are going down. So we kind of have a double benefit there. As firms raise the price in the inelastic range, they get a higher revenue and they get lower costs. There may be long-run reasons why a company might want to keep the price below 12 temporarily to try and spur market share, to get people to try the product, right? You're kind of making an investment in future sales, but you're sacrificing some short-run profit to do that. So we have the maximum revenue here at 12 times 12, price of 12 and quantity of 12. Notice also they show the slope of marginal revenue is 2 times the slope of demand. And that's the way we're going to formulate our marginal revenue function. In the next video, we'll talk about solving for the price and quantity that we would see for a monopolist.